What if I told you that after staying awake just one night, your brain starts to hallucinate, your emotions spin out of control, and your memory begins to collapse? That's not science fiction. It's what happens inside you after only 24 hours without sleep. We think an all-nighter just makes us groggy, but the truth is darker. In a single sleepless day, your brain spirals into chaos, focus shatters, emotions flare, and even the structure of your brain tissue begins to change. Push further, and reality itself starts to warp. Shadows flicker, whispers echo, and the familiar world bends into something strange. This isn't just fatigue. It's a neurological breakdown unfolding in real time. Today, we uncover how quickly sleeplessness dismantles the mind, and why just 24 hours awake can send your brain into free fall. Let's get started. Sleep, often relegated to the bottom of our priority list in modern society, is a fundamental pillar of human health, as essential as breathing, hydration, and nourishment. Yet, in our increasingly demanding world, millions sacrifice sleep for work, social obligations, or the endless scroll of social media. The World Health Organization has declared sleep loss an epidemic in industrialized nations, with an estimated 1/3 of adults regularly getting insufficient sleep. The common misconception is that sleep deprivation merely results in tiredness, an inconvenience to be overcome with caffeine and willpower. This documentary will expose the disturbing reality. Just 24 hours without sleep can trigger a cascade of neurological events that compromise our cognitive abilities, emotional stability, and overall well-being in ways that mirror serious mental disorders and intoxication. As neuroscientist Dr. Claudia Aguirre notes, sleep isn't just rest for the brain. It's an active process essential for neural maintenance. Without it, our brain's ability to function quickly deteriorates at every level, from basic reflexes to our highest cognitive functions. Before we explore the consequences of sleep deprivation, we must first understand why sleep is so crucial for brain function. Several theories attempt to explain sleep's vital role. The energy conservation theory proposes that sleep reduces energy expenditure, allowing the body to conserve resources. The restorative theory suggests sleep allows for muscle and tissue repair, protein synthesis, and hormone release, crucial for growth and development. More recent research emphasizes the brain plasticity theory, highlighting sleep's role in synaptic plasticity, the process by which the brain strengthens or weakens connections between neurons, essential for learning, memory, and adaptation. During sleep, the brain processes information gathered throughout the day, consolidates memories, and clears out metabolic waste products that accumulate during waking hours. Sleep serves as the brain's janitorial service, explains Dr. Macon Nadergaard, who discovered the glymphatic system, the brain's waste clearance mechanism. While we sleep, the brain cells actually shrink, creating wider channels for cerebrospinal fluid to flow and flush out toxins that build up during wakefulness, including beta amyloid, a protein associated with Alzheimer's disease. This intricate process is disrupted when we deprive ourselves of sleep, leaving our brains cluttered with cellular debris and without the essential maintenance it requires to function optimally. The consequences of this disruption begin to manifest almost immediately. One of the most immediate and noticeable effects of sleep deprivation is impaired cognitive function. Studies have shown that after just one night without sleep, the brain's ability to focus, problem solve, and process information plummets dramatically. The prefrontal cortex, the brain's command center responsible for higher-level cognitive processes, is particularly vulnerable. Dr. William Kilgore, a neuropsychologist at the University of Arizona, has extensively studied the effects of sleep deprivation on cognitive function. After 24 hours without sleep, he explains, we see a 25 to 30% decline in cognitive performance. Tasks requiring attention, working memory, and logical reasoning become significantly more difficult. The sleep-deprived brain simply cannot maintain the neural activity required for optimal function. This impairment translates into poor decision-making, reduced attention span, and decreased situational awareness. Imagine trying to drive a car with a foggy windshield and delayed reflexes. That's the cognitive equivalent of a sleep-deprived brain. Even more alarming, sleep-deprived individuals often underestimate their impairment, believing they're performing better than they actually are. A dangerous form of cognitive blindness. The devastating consequences of sleep-deprived decision-making are tragically illustrated by the Exxon Valdez oil spill. On March 24, 1989, the oil tanker Exxon Valdez ran aground on Bligh Reef in Prince William Sound, Alaska, spilling approximately 11 million gallons of crude oil into pristine waters. Investigations revealed that the ship's third mate, Gregory Cousins, was severely sleep-deprived when he made critical errors in navigation. Having worked over 18 hours straight, his judgment was compromised, his reaction time slowed, and his ability to process complex information severely diminished. The National Transportation Safety Board cited fatigue as a significant contributing factor to the disaster. This environmental catastrophe, which killed hundreds of thousands of seabirds, otters, seals, and whales, and devastated local fishing communities, serves as a stark reminder of how even a single night of missed sleep can have catastrophic consequences. It's not merely about feeling tired. It's about fundamentally altered brain function that can lead to errors with far-reaching implications. Emotional instability, riding the emotional roller coaster. Sleep deprivation not only clouds our thinking but also throws our emotions into disarray. The amygdala, the brain's emotional center, becomes hyperactive in sleep-deprived individuals. Meanwhile, connections between the amygdala and the prefrontal cortex, which normally help regulate emotional responses, weaken significantly. This neurological imbalance results in exaggerated emotional responses, increased irritability, and a diminished capacity to cope with stress. A study published in the Journal of Neuroscience found that sleep-deprived individuals were up to 60% more emotionally reactive to negative stimuli compared to well-rested individuals. What we're seeing is essentially an emotional brain unleashed, explains Dr. Matthew Walker, professor of neuroscience and psychology at UC Berkeley. Without sleep, the brain reverts to a primitive pattern of uncontrolled reactivity. The prefrontal cortex, which acts as our emotional brake pedal, goes offline, while the amygdala, our emotional accelerator, becomes overactive. This emotional volatility can strain relationships, impair work performance, and significantly reduce overall quality of life. For individuals with pre-existing mood disorders, even a single night of sleep deprivation can trigger severe episodes, underscoring sleep's critical role in emotional regulation. Perhaps the most alarming consequence of 24 hours without sleep is the temporary neurological breakdown that can occur. Research utilizing advanced neuroimaging techniques indicates that sleep deprivation can lead to transient brain shrinkage. MRI scans have shown that a lack of sleep can cause a temporary decrease in gray matter volume, affecting areas responsible for attention, decision-making, and memory. Dr. Chiara Tirelli, a neuroscientist specializing in sleep research, explains, during extended wakefulness, synapses throughout the brain become increasingly saturated with information. Without sleep's pruning mechanisms, this leads to energetic and spatial constraints, temporarily affecting brain volume and function. Furthermore, prolonged wakefulness leads to an accumulation of adenosine, a neurotransmitter that promotes sleep. High levels of adenosine contribute to cognitive decline and can even induce hallucinations, causing individuals to see or hear things that aren't there, a frightening and potentially dangerous side effect. As wakefulness extends beyond 24 hours, some individuals report visual and auditory distortions, shadows that appear to move, voices that seem to whisper. These perceptual abnormalities represent the brain's inability to properly process sensory information without adequate rest, creating a disturbing altered state that mimics aspects of psychosis. Real-world examples: when sleep deprivation becomes dangerous. The dangers of sleep deprivation extend far beyond individual impairment. In 2003, a groundbreaking study by Dr. David Dinges at the University of Pennsylvania revealed that individuals deprived of sleep for 24 hours performed as poorly on cognitive tests as those legally intoxicated with a blood alcohol concentration of 0.10%, higher than the legal limit for driving in most countries. This finding has significant implications for professions requiring constant alertness, such as pilots, air traffic controllers, surgeons, and long-haul truck drivers. The National Highway Traffic Safety Administration estimates that drowsy driving is responsible for approximately 6,400 fatal crashes each year in the United States, a figure many experts believe is significantly underreported. Driving while severely sleep-deprived isn't just dangerous, it's comparable to driving drunk, says Dr. Charles Cheisler, Chief of Sleep Medicine at Brigham and Women's Hospital. Yet while we have strict social taboos against drunk driving, we often celebrate the ability to push through sleep deprivation as a sign of dedication or strength. Medical residents, notorious for their long and demanding shifts, provide another compelling example of institutionalized sleep deprivation. For decades, residents were expected to work shifts lasting 24 to 36 hours, a practice justified as necessary for training and continuity of care. Research consistently shows that sleep-deprived residents are more prone to making medical errors, jeopardizing patient safety. A landmark study published in the New England Journal of Medicine found that interns working extended shifts made 36% more serious medical errors and 460% more diagnostic errors compared to those working shorter shifts. Dr. Christopher Landrigan, Research Director of the Sleep and Patient Safety Program at Brigham and Women's Hospital, has been at the forefront of reforming medical training. We've documented that when doctors work shifts of 24 hours or longer, the risk of making serious diagnostic errors increases dramatically, as does the risk of attentional failures during critical procedures. This alarming reality has prompted reforms in medical training programs worldwide, emphasizing the importance of adequate rest and implementing strategies to mitigate the risks associated with sleep deprivation. However, many institutions continue to push the boundaries of human endurance, often with devastating consequences. Health consequences: a weakened system. Beyond immediate cognitive and emotional impacts, sleep deprivation poses significant long-term health risks. Just 24 hours without sleep can weaken the immune system, increasing susceptibility to infections. Natural killer cells, critical for fighting viral infections and cancer, decrease in number and activity after a single night without sleep. Sleep deprivation also disrupts metabolic processes, potentially contributing to weight gain and increasing the risk of chronic conditions like diabetes and cardiovascular disease. Studies have linked sleep deprivation to increased levels of C-reactive protein, a marker of inflammation associated with heart disease. Even brief sleep deprivation triggers an inflammatory response throughout the body, explains Dr. Michael Irwin, director of the Cousins Center for Psychoneuroimmunology. We see immediate increases in inflammatory cytokines after just one night of poor sleep, which, if chronic, can contribute to various disease states. The evidence is clear: sleep is not a luxury, but a necessity for maintaining both physical and mental health. Even a single 24-hour period without sleep begins a cascade of physiological changes that extend far beyond temporary fatigue. The sleep cycle, a delicate dance. Understanding the science of sleep further underscores its importance. Sleep occurs in cycles of approximately 90 minutes, consisting of two main types: non-REM, rapid eye movement, and REM sleep. Non-REM sleep is divided into 3 stages, each playing a distinct role in physical and mental restoration. Stage 1 is the lightest stage, where the body begins to relax, and brain waves slow. Stage 2 is characterized by deeper sleep, slower heart rate, and lower body temperature. Stage 3, known as slow-wave sleep, is essential for physical recovery and immune function. REM sleep, marked by rapid eye movements and vivid dreams, is crucial for cognitive functions like memory consolidation and emotional processing. Each sleep stage serves a specific purpose, notes Dr. Sarah Mednick, sleep researcher and author. Slow-wave sleep physically restores the body, while REM sleep helps process emotional experiences and consolidate learning. Skip either one, and you're missing critical restorative processes. Disrupting these carefully orchestrated stages through sleep deprivation has far-reaching consequences. When we stay awake for 24 hours straight, we don't just miss a night of sleep, we interrupt a complex biological process essential for brain health and function. Upon finally sleeping after extended wakefulness, the brain attempts to compensate with longer periods of deep sleep. But certain aspects of the normal sleep architecture remain disrupted, preventing full recovery. Expert commentary, the voice of sleep science. Dr. Matthew Walker, a prominent sleep scientist and author of the bestseller Why We Sleep, emphasizes the critical role of sleep in maintaining overall health. He refers to sleep as the Swiss Army knife of health, highlighting its multifaceted benefits. Sleep is the single most effective thing we can do to reset our brain and body health each day, Dr. Walker explains. During sleep, we essentially service our finely tuned physiological machinery, preparing it for optimal performance the next day. Dr. Walker explains that sleep deprivation impairs the brain's ability to form new memories, hindering learning and information retention. After 24 hours without sleep, the hippocampus, essentially the brain's memory inbox, shuts down almost completely. New information simply has nowhere to go. He also emphasizes sleep's crucial role in emotional regulation, noting that sleep loss increases activity in the amygdala, leading to heightened emotional reactivity. Without sufficient sleep, we become all emotional accelerator and no break. The neural pathways that normally keep our emotions in check weaken dramatically. This scientific consensus underscores a sobering reality. When we deprive ourselves of sleep, we're not simply operating at a reduced capacity. We're fundamentally altering our brain's ability to function across virtually every domain. Reflection, a wake-up call for society. The evidence presented paints a clear picture. Even a single night without sleep can trigger a cascade of negative effects, impacting our cognition, emotions, and physical health. If 24 hours of sleep deprivation can cause such significant breakdowns in memory, emotional control, and even perception, what are the implications for the millions chronically sleep-deprived? Our modern society often glorifies sleeplessness as a badge of honor, a sign of dedication, productivity, or resilience. We celebrate the entrepreneur working through the night, the student cramming for exams, the parent functioning on minimal sleep. Yet the science is unequivocal. This culture of sleep deprivation comes at an enormous cost to our cognitive abilities, emotional well-being, and physical health. We've created a society that for the first time in human history makes sleep optional, observes Dr. Russell Foster, professor of circadian neuroscience at Oxford University. But our biology hasn't changed. We're operating with Stone Age bodies in a digital age environment. This question demands our attention and necessitates a societal shift in how we prioritize sleep. The lost knowledge here isn't ancient wisdom, but contemporary science that we've chosen to ignore. Humans simply cannot function optimally without adequate sleep. And the consequences of this oversight affect everything from individual health to public safety. The insights shared in this documentary underscore the urgent need to prioritize sleep. It's time to treat sleep with the same importance we afford nutrition and exercise. Here are practical steps to improve your sleep hygiene. 1. Establish a consistent sleep schedule. Go to bed and wake up at the same time every day, even on weekends, to regulate your body's natural sleep-wake cycle. This consistency reinforces your circadian rhythm, making it easier to fall asleep and wake up naturally. 2. Create a relaxing bedtime routine. Wind down before bed with calming activities like reading, taking a warm bath, or listening to soothing music. Avoid stimulating or stressful activities in the hour before sleep to signal to your brain that it's time to transition to rest. 3. Optimize your sleep environment. Ensure your bedroom is cool, around 65 degrees Fahrenheit, 18 degrees Celsius, dark and quiet, conducive to restful sleep. Consider blackout curtains, white noise machines, or earplugs if necessary. Your sleep environment should be a sanctuary dedicated to rest. 4. Limit screen time before bed. The blue light emitted from electronic devices interferes with melatonin production, a hormone regulating sleep. Try to avoid screens at least 1 hour before bedtime, or use blue light filtering glasses if screen use is unavoidable. 5. Avoid caffeine and alcohol before bed. These substances can disrupt your sleep cycle and prevent you from achieving deep, restorative sleep. Caffeine can remain in your system for 6 to 8 hours, while alcohol, though initially sedating, leads to fragmented sleep later in the night. 6. Seek professional help if needed. If you consistently struggle with sleep, consult a healthcare professional to rule out any underlying sleep disorders such as sleep apnea, insomnia, or restless leg syndrome. Effective treatments exist for most sleep disorders. By prioritizing sleep, we can enhance our cognitive function, emotional well-being, and overall health. The 24-hour wake-up call isn't just about understanding what happens during a single sleepless night. It's about recognizing sleep as a fundamental biological need that deserves our respect and protection. Remember, sleep is not a luxury but a necessity for our brains to function as they were designed to. In a world that increasingly demands our attention around the clock, protecting our sleep might be the most revolutionary act of self-care and the most important investment in our cognitive, emotional, and physical well-being. The next time you consider sacrificing sleep, remember what science has revealed. Your brain cannot operate without it. Protect it, prioritize it, and give your brain the rest it deserves to thrive.